We are working on examples using the chain rule, and here we have an example with many functions plugged inside of each other, and so that's where the chain rule gets its name. You keep chaining on the derivatives of the interior functions. So you always want to identify all of your functions starting with the outside function. In this case it is secant, and you want to identify the derivatives of your functions. And so the derivative of secant is secant times tangent. For this example, the next function, notice, is actually a square. We have cosine squared inside the secant, so the square is actually the next function. So the next function is something being squared. The derivative of that, following the power rule, will be 2 times something to the first power. Then next, inside of the square, we have cosine, and the derivative of cosine is negative sine. And then lastly, inside of the cosine, we have pi times x, and that's a linear function whose slope is pi, so the derivative of pi x is pi. So by the chain rule, the derivative of my original function, secant of cosine squared of pi x, will be secant with the cosine squared of pi x as its input times tangent with cosine squared of pi x as its input. Then we're going to multiply by the derivative of the square, which is 2, but inside of the derivative of the square will be cosine of pi x. And then we multiply by the derivative of cosine, which is negative sine, and inside of it is pi times x. And lastly, we're going to multiply by the derivative of pi x, which is pi. There's not a whole lot you could do to clean that up, except for put the constants multiplied in the front. So I think for our example, we will leave it at that. We've got our derivative of our outside function, then we have the derivative of the next function, then the derivative of the next function, and the derivative of the last function.